So we're talking about a linear dimension, and you only have the idea of how to get curves if they're circles. Okay? And I would like to do some of that tomorrow, dealing with the one you know, how you find the circumference of a circle. Okay? That arc length. But today I'm going to show you, and what we're going to do today, tomorrow, first part of Thursday, will be a lot of review stuff. Jeff?
So are we skipping over 6.4 for right now?
We are skipping over 3.4. Juniors, you will come back to it. Seniors, you may... You know, I was talking to somebody who attends one of our area public high schools, and the seniors who are taking college credit courses have to come back after graduation.
That's a good idea.
I think so too.
Hey, do you want to die?
I'm not coming back.
Well,
why would we have to come back after graduation?
I'm definitely.
I'm just saying that was happening at another school.
Mr. Kramer, I
What
want to.
No.
They also give free school.
I won't see.
No, but they maybe would.
Oh, wait, they don't.
But anyway, you guys are not, and so the exam
Is that Tuesday, Wednesday?
Yeah.
is Tuesday and Wednesday of next week. Tuesday we'll do the integral, or excuse me, the limit and differential part, and on Wednesday we'll do the integral. Yes.
May we use decimals for both days?
Yes, you may. And we'll talk a little bit more when I get it shaped up a little bit, but maybe a 3x5 card and that kind of stuff too. That's not totally without possibility. Yes.
Is that important bit of information I just missed? What did I just miss? Oh, when we have the exam?
Yeah. Okay. We have Derek with us today, and he's going to do some videoing. And so here we go. I would like to find the length of a curve. And I think you can see that that would be possibly a very important thing to do, because at this point, you can only go straight line stuff or around a circle. And there are a lot of other functions. This is going to be a significant amount of review also, because to do this, we're going to find derivatives and we're going to find integrals working together. So here we go. I'd like to find the length of the curve from here to over here, that curve length. And so what I'm going to do is to break this up into little intervals, and this is going to be x sub 1, or x sub 0, and this is going to be x sub 1, that's going to be x sub 2, and then over here someplace, I'm going to have an x sub k minus 1, and this is going to be an x sub k. And we're going to run all the way up here to x sub n. Okay, yes?
Is this a proof that we have to memorize?
This is more deriving it, and so you should know how to do this, yes. Okay, so here we go. I'm going to take this one right here and blow it up for me so I can see what's happening. I also know that b minus a over n is equal to delta x. All my delta x's are the same size. Okay? So, this is going to be x sub k minus 1, and this is going to be x sub k. Okay? Now, so what I'm going to do is I'm going to find this length of arc, but I'm going to approximate it with this length. Okay? What is the length from here to here? Well, that length is going to be equal to the square root of this length right here, which is nothing more than delta x. And this side here, now this is going to be a little bit different. This is going to be delta y sub k, because each of these could be different from the one before. All of these are the same, but these differ from one to the other. Okay? And so now, so I'm going to first go from here to here, and this length of the red line is going to be delta x quantity squared plus delta y sub k quantity squared. Questions on that? Okay, yes,
What did you just do that for?
because I wanted to know this length and this length.
So why did you square?
Okay, oh, because this length here is, this point from here would be x sub k minus 1 minus x sub k, that's the x values here, that quantity squared, square root of, plus y sub k minus 1 minus y sub k, quantity squared. The old distance formula.
Oh.
The change in the x's over the change in y's kind of thing. And this is just a shortcut. Okay, any questions about this over here now? Where I am and what I'm doing? Shoot, he's gone already.
Wait.
Okay, now, very crucial you're having with me, because now we're going to do some algebra. Okay, so what I'm going to do, and I'm going to divide each of these by delta x squared, this delta x squared, and I'm going to put back here delta x squared. There's a method for what I'm doing, and oh, I've got to put a bracket around here like this. See this? Now, the only way I put this down here is if I put it up here, because this over this is 1. Any questions on that? Now, if you are lost in a few minutes again, make certain you ask the question, but I hope you're with me here. Now, what does this simplify into? That's a 1. And I'm going to take this one out of the square root and make this delta x.
Can you do that?
This is 1. So that's here. And this one is inside with a square, so I'll take the square root. Square root of the squared is this number over here. Okay, now this. I want to talk about this a little bit. What is this thing? Well, that's delta y over delta x, which is the slope of this line. Lo and behold, that's the slope of this line, which is a big deal.
Whoa.
Okay? Okay, that's nice. So that's there, but hey, there's something else nice. We learned mean value theorem. And the mean value theorem said over here, there is a line that's parallel to this line, and it is f invert the derivative at some point here like this. That's going to be right here. This is going to be the same as this, and that's going to be down here like this. And this point is x sub k bar, which the mean value theorem says. Some place across here where this slope is going to be the same as this slope, and it's going to happen at the first derivative at this point. Questions on that? Yes?
What does it say? F prime of what?
This here says f prime at x bar sub k. That means some point in this interval that's going to happen, and it's at this point. Okay? Any questions about that? Okay, that's all hard work. Now look what comes out of this. I said this here was like this here, so what I'm going to put here is x, first derivative, x bar sub k, like this, and then I have to square this. Okay? Okay, now the next thing I'm going to do is I'm going to take this one and take all of these. This is just one of them right here. I'm going to just do all of them now, and I can do all of them by doing this. And I'm going to go k equals 1 to n. Now I've got all that done. That was quick. See that? I just added all these up. And the next thing I'm going to do is say, oh, I want to do something else. I want to make that, I would do an infinite number of these as n approaches infinity. And then all of a sudden I say, hey, I know something. We've been doing this. This whole business is the integral. There is dx. Bingo. And this business is from back up here. So this is a to b. And this is the square root of 1 plus f prime of x quantity squared. And that's going to be exactly equal to that length. See, this here was approximately equal to this length here. is approximately equal to that. Yes, Shannon?
Is the f prime of x on the bottom is squared there?
Yeah, this is squared.
Okay.
Now that's squared. Okay? Okay. Now that is tremendous stuff. Notice what we have. We have an integral with a derivative inside. And now we're going to have a few procedures that come from that. Otherwise, if we just start working with this, to say, what in the world is that all about? Now I'm going to show you, and now I could show some of you this with some very short ones, just straight line. That'll work, okay? Tomorrow, I don't have the lecture prepared all the way yet, but I have it in my mind. I would like to do a little circumference of circles stuff. The only unfortunate part of that, that's a little bit difficult. So we're going to do some other ones today, which aren't all that difficult. They're at least, I hope in the next 15 minutes to do 3 of them. One by the calculator, which I find this book is interesting, and that it suggests we do that. Okay, the first one up is this one. Oops, this way. I have it drawn on this. Okay, here's the function right here. E to the x. And the reason I do this one is one of the easiest ones you can do. Okay, it's not that all that difficult. And it's plus this, and that's by design, so it turns out nice. Everything is cool. Okay, and I'm going to go from 0 to pi over 2, and I'm again doing that because it's nice. Okay, and so just to show you, this is my function, which is this black line. And we're going to go from this point right here to this point up here. Now, as you look at it, how long do you think that is? Approximately. I don't think so. This is 2,
We'll
0,
go
2,
with,
4.
I'm gonna go 2.5.
Okay, it's a tiny bit more than 2. Yeah. It's a tiny, okay, that's just to get an approximation. And so what we're going to do is figure out how long this line is. Okay? And so that's the text. What we're going to do, and here we go. Watch what happens in terms of how this goes. Probably better write the formula first. The length of the arc is going to be the integral from, just a second. Let me just erase this a minute and write that function up here a minute so we get that. We're going to go, it's 2e to the x minus 1/8 e to the negative x like this. This is my function f of x. I'm going to save myself a little space there, and the length of that we want to find from 0 to ln of 2, and my function is going to be then the square root of 1 plus f prime x squared dx. Okay? Now, I need to find out what this is, so I'll find the derivative of that first. Okay? So f prime of this happens to be equal to, see now this is a review of derivatives.
2e to the x plus 1 plus
1/8.
Oh, yeah. Okay.
Oh, there's a minus here.
Yeah.
Okay, now down here, I'm going to do something else. This is not so terribly easy. I need this squared. Okay? And I know how to do this. If I have a plus b, I square it. That's going to be a squared plus 2ab plus b squared, right?
Yeah.
Well, we're going to go back to that today, and we're going to square this. 2e to the x plus 1 over 8e to the negative x. Square that. Okay? So, I don't know if you can go this fast. If you need me to slow up, I will. Otherwise, I'll really rip through this. I need this term squared, so this is going to be 4
e to the x.
2x, like that.
Yeah.
Okay, now I'm going to square this on the back end next, and I'll do the middle one in a minute.
Plus.
So that's going to be
164
1 over 64
e to the 2x.
negative 2x. Okay, so we've got 1 over 64 e to the negative 2x over here. Now let's go for the middle term. And that's going to take us just a minute to get that. and it's going to be, middle term is going to be 2 times the first term, which is 2e to the x, see, 2 to that, times 1/8 to the e to the negative x. What does that turn out to be? Very nice, very easy.
480.
And by the way, this is a minus to be, no, this is a plus. So this is, let's see.
Yeah, you kinda.
Okay, I have to back up a little bit. At this point, I see a problem. This was supposed to be a plus,
Yeah, you were.
Oh.
and this is supposed to be a minus. And we only have a problem when we get down here. Okay, now, so this is going to be like a minus here and a minus here, and so this will be a minus. What does this turn out to be?
I don't know. Let's work through that.
A squared.
1.
Oh, yeah.
2 times 2 is 4.
4
Times 1/8 is a half. And this times this is just 1.
Cool.
Okay, we have here e to the x times e to the minus x, which is
Oh.
e to the x minus x, or e to the x over e to the x, whatever way you want to look at it, is 1. Okay? Any questions about that?
Can you do that part again?
Pardon?
Can you do what you just said again?
For this middle term?
Yes.
Okay, this is 2, 2, and 1/8. That's a half.
Okay.
And then this had times this here, e to the x times e to the negative x is just a 1.
Alrighty.
Okay? Because x minus x is 0, e to the 0 is 1. Okay? Now, hey, you're with me on this? Because this is the pattern that they follow, and something really cool is going to happen in a moment. I want to get rid of this, and I have this, so I'm going to keep that. I'm going to get rid of this at this point. And now look what happens. This here becomes 0 to ln of 2, and this whole quantity becomes the square root of 1 plus 4e to the 2x minus 1/2 plus 1 over 64 e to the negative 2x dx. Right?
Yeah.
Okay, by the way, yeah.
Is the dx outside of the square root?
Yes, it is. It's way out here. Okay, now, any matter races?
Where did the 1 come from?
Right over there.
It's always there,
On
Derek.
the top.
Oh, it's on.
Okay, now, Derek, what is 1 minus a half?
1.
Half,
That's a plus, right? So can I erase this one and put a plus here?
please.
Yes.
Okay, so I'm going to put a plus here, and I'm going to erase this. Okay, now look what happens. And this is pretty typical of these problems if you have them set up right. That's out of here. Now look at this. This here is a square. Underneath here is a perfect square.
Oh boy.
Because we just did it, so I'm going to just undo it. If I undo this, this becomes 2e to the x. That becomes, now it's going to be a plus. 1 over 8e to the negative x. If I square this, I get this.
Whoa, no. Yeah.
Okay? Okay? Any questions on that? Okay, now, let me just do this a minute. At this point,
You can just get rid of the.
yeah, see, I'll get rid of the square roots here, and I just have this. And so I
But
think,
it's not squared.
then it's not, okay, great, thank you. So it's going to be like this. I'm going to get rid of this. Dx is back here, and I'm going from 0 to ln of 2. With me? Okay, this is out of here. Now, what's the antiderivative of this?
2dx.
2e to the x. What's the antiderivative of that?
Minus 1. Negative.
Okay, now we're going to evaluate this from 0 to ln of 2. By the way, what number were we looking for and we thought the length was?
Round 2.
Round
Just a
2.
little bit more.
Okay, so here we go. Now, this part isn't too hard. What is this?
4.
Okay, that's 4. What does this turn out to be? That's a little tricky. So here we go. Watch this. And we'll probably have a little more review of this on Friday. This is ln of a negative ln of 2. See what I have here? I'm doing this. And you see what happens here?
Yeah.
Okay, now this negative could be brought inside here to a -1, like that, right?
Yep.
Yep.
Okay, now, if that's the case,
It's a negative.
do I like this or not?
Yep.
Yeah, I think I do. That turns out to be, what is this quantity right here?
Negative 2.
Two.
I don't think so.
1/2.
1/2.
1/2.
Alright.
So it's a -1/8 times a half, which is a -1/16.
That's not good, too.
Oh, we're not finished yet. We haven't done this one yet.
Darn it.
Okay, and so this in here gives me a -2.
2.
Okay, now we're less than 2, so we have a trouble. But we still haven't done this one yet. And so this is going to be, let me do it this way. This goes to 0, so this is going to be +1/8, right? Oopsie. No. It's going to turn out to be that. If I put this in here, it gives me a -1/8 this way. And now minus. So see what I have here? 4 minus 1/16 minus 2 plus 2/16. So this gives me 2 and 1/16,
Oh, boy.
which is 33/16. And if you check your book, that's the correct answer. Okay? Okay, now, that is an interesting one. Let's see here. This one's going to be a lot faster. Again, total, inside there's some real nice review of, Aaron, I'm sorry, but it's substitution. And this is this function like goes this way. F of x equals x to the 3/2.
Can you move this down?
Yeah.
Do we
Okay.
just stop in 5 minutes?
Yep, I will try. Okay, this is a little function that runs this way, and I'm going to go from 0, in this problem, 0 to 4. 0 to 4, like this, that interval. Okay? Now, I think you know the formula, so I'm not going to write that down, but I'll just take the first derivatives. F prime of x is equal to what? 3/2 x to the -1/2. Okay, got that? Questions? Okay, now,
How do you get the 1/2 off?
drop it by 1. We're finding derivatives now, not integrals. Okay, now we have to square this. So I'll just do this, square this like this, and then I get 9/4. Oh, that cool? Okay, what's my length? It's going to be the integral from 0 to 4. And in this case, it's going to be the square root of 1 plus 9/4 x dx. Okay, now,
So you can,
yeah,
okay, so you're putting in the 9 to the 4th because you squared the derivative already up there?
yeah.
Okay.
Okay, now, so that's there, and I'm stuck unless I know substitution, and I know substitution. So u is going to equal 1 plus 9/4 x.
Oh, boy.
Okay, so du equals 9/4 dx.
Oh.
Okay, now, so you can keep track of some things. Over here, I need a 9/4. 9/4 here, so I'll put a 4/9 here. Okay? See that? Then, I better also do this a minute. Here is an x, and here's a u, and this is going to be a 0, and this is going to be a 4, and this is going to be a
1,
and this is going to be a
10,
9.
okay? Okay, got that. So my new integral is going to be 4/9, and there's going to be a du here instead of a dx, and this is going to be 1 to 10, and this is going to be u to the 1/2. Okay? And that's not too difficult. So this is equal to 4/9, and this is going to be u to the 3/2, 3, 2 up here, and then we're going to evaluate that from 1 to 10. Okay? That one's pretty straightforward. Now, oh, I have 3 minutes. Yes?
With the square rooting of f prime of x, how can you square that and have it still be f prime of x?
Okay. In here, I needed the first derivative squared.
Oh, okay, I see.
Okay? Yeah, and isn't that absolutely amazing? That's how it works in the world, okay? Where you're combining integrals and derivatives, and here even with squares, okay?
So you square the derivative and integral.
Yes,
Okay.
yes. Okay, now, will you go, if these are the problems I'm assigning, up there, I would like you to take a look at 11 and 13, okay? Because something very special has to happen there. Because those integrals are extremely difficult. For your information, if you go on to Calc 2, you're going to find a few more techniques to find integrals, and then all of a sudden you're going to say, I can't do this. Nor can anybody else. Or there are certain patterns that work, okay? So then you're going to have to learn other strategies, and you'll be going back to some algebra stuff. Higher level algebra stuff, okay? So, hey, we're seeing all these wonderful things happen before our eyes, but they don't always work that way. Okay, look at 11 and 13. What does it say? It says, write and simplify the integral that gives the arc length, okay, of the following curves, and then it says, if necessary, use a calculator to calculate them. You're going to have to do that. Do you know how to find derivatives on this calculator?
No.
Okay. Then we are going to do one real quickly, and since I don't have a lot of time, you can do these complicated ones in there. But here's what we're going to do. Get your calculator, and in y equals, now what is really kind of amazing, you guys haven't found this before. Because you could have done all your integral problems this way and found the answers. Okay? So, what we're going to do, let's just do a very simple one and just go x squared. Okay? That's a nice little curve. Y sub 1 equals x squared. And do zoom standard, do it standard. See that?
Where, what?
Okay, now, okay, we're just about finished. I'm sorry, but we're almost finished here. You got this on your screen?
Yeah.
You see second trace, calculate above that. And what do you think 7 says? I've got to be joking. And the thing is, I can't blame you. I'm just to do that too. And it's a nice way to find answers.
We could have done this the
now,
entire time.
oh yes, but you will see what is above it. There's derivative. Okay, now, here's how you do it. I would like to go from 0. It says the lower limit. I can go wherever I want to. So I'll put a 0 in. How high do you want to go? Not very high. Shall we go 2 or 3? 2. Okay. And so this is upper limit 2. And there you got it. And it's 2.66.
That's cruel.
Okay, now, let me do.
You found this on the
So you can do this. Hey guys, quickly yet. One more thing. I would like to redo this problem, and I'd like to go from a -2 to 3. From -2 to 3, and I'd like to erase what I have on the screen. So what you can do to erase that, you go to your draw function, above program, you see draw, it says clear. And if you clear it, you see what happens to your screen. Okay? Now let's redo it, and we're going to go from a negative, oopsie, 7 here, let's go, 7. I said, I think a -2 to 3. 11.66.
Wait, what did you say for
Is that giving you the area?
Oh yes, that gives you the area under the curve.
Okay, so that's giving you the area under the curve.
Yes, it does. Okay, you may play with that a little bit, but it's amazing what comes out of this. Now, Dylan has a cast system, and it can do this, but it can also spit out the, yeah. Okay, now.
why would you say this?
Okay.
You done?